Thank you. Hi, everyone. So just give you a very short background. In the last couple of years, the Hungarian WWF office, together with the Bulgarian and the Romanian one, we worked actively on the biomass sustainability issues. And so I will just bring you the most craziest example of the unsustainable part, the transformation sector through the Hungarian example. Let's start with the good news, because there won't be any other. I wasn't sure that I will fit to my 25 minutes, but Gabriele already provided a very good background on the baseline, so I will just complement her information. So here again, the same information, very similar sites. So on EU level, you can see that between 2000 and 2018, the primary solid biomass use almost doubled. And I also bring parallelly the issue with the LULUCF sink. So this is a graph from the European Environmental Agency. You can see that the most important, I hope you can see my mouse. No. So here you can see the red line. This is the total sequestered or the actual, thanks. So this is the most important information, the total emission or the negative emission of the LULUCF sector. And what is important that here you can see that what is the prediction for the next decades. So the EA assessed the different promises in the, I think it was from the draft National Energy and Climate Plans, that what member states are planning in terms of increasing or staying the carbon sink. And so the big issue is that by 2030, this number should be, according to the LULUCF regulation, minus 310 million tons per year. But as you can see, we are really far from that. And it's quite obvious that within this remaining 6 years, this aim of or this target of the LULUCF regulation won't be reached. Of course, this is a complex issue because the LULUCF sink is also related to the aging of the forest, because so as the forest is saturating, probably it sequesters less carbon, but of course it's very strongly interlinked with the increasing biomass use. Then my last slide on EU level, I think Gabriel, you also had a similar one. This is about the increase of the share of the fuel wood from the total logging. So here you can see that even on EU level, the share of fuel from the total logging, it's increased again between 2000 and 2022 from around 18% to 25%. And there are big differences among the countries. We have countries where the share it's already around 50 or even more %. And again, it's not only this share increased, but also the actual removal increased. So the total wood removal increased between these two dates by 26%. And the removal of firewood, it's increased by 80%. So it's a really big change. And now let's focus on Hungary. Here, I think that this only difference is that, again, I'm having a little bit longer historical dates, but so this is the solid biomass used by the different sectors. What can be interesting is the use of the household sectors. Again, referring to what Gabriela just said at the end of the presentation, there is a very huge uncertainty in terms of the biomass, actual biomass use, and huge statistical gaps. And this is mainly related to the household biomass use, because it's you don't have the meter in the garden of the households. There are mainly on assumptions. So before 2020, I think it was in 2026, this statistics was based on the forestry statistics, and then they changed the methodology, and they assessed the actual heat demand of the building stock. Then they reduced those energy consumptions that can be measured, mainly natural gas. And then they revised the historical statistics until 2005. Yes, and so that's why there is this huge gap. But so what it's also interesting that so from you can see that according to the statistics in the last around 10 years there was a decrease in the residential firewood use, but this is mainly because of the natural gas price, because there are many of the households they have the access to the natural gas grid, and they are using the fuel according to the economical sense, let's say like this. And since the firewood price increased compared to the price of the natural gas, simply they started to use less and less wood. But what I will talk about more, it's about this part, so the transformation sector. And so just to have like a complete picture, I also bring here you the reported carbon sink of the LULUCF sector. So this is from the National Inventory Report. Interestingly, so if we again compare from 2000 and so the last 2 decades, there is an increase in the papers. I'm not a forestry expert. I'm not pretty sure about the results. I know that many forests stands per pound in the statistics. So on paper, the forest area increased significantly, and you can also see that year by year the actual sink or the reported sink, sorry, it's fluctuated a lot. So it's also a question that regarding the methodology of this. But what is more important, it's about the future. So I bring here again a slide from the long-term climate strategy, and so this is the official modeling of the LULUCF sink with 2 scenarios. So here we have the logging rate of the business as usual, so it's around 7 million cubic meters per year. And then there is an assumed increased logging rate to 8.5 million cubic meter per year. It's quite obvious that so if you increase the logging rate, then the carbon sink will decrease. And the big problem is that so our LULUCF commitment by 2030 is minus 1.7 million tons of CO2. So it's the gap, it's again really huge, and I will talk about that what can be done here to decrease this gap. Then let's see that where the wood comes from. So here you can see that so in terms of the forestry biomass, which this is actually most of the solid biomass which is used in Hungary. So we have 6 forestry categories according to its naturalness. You're right, it's only 5 in the graph. We have a natural forest category, but it's so small that if I would put it in the graph, then I to be visible, I had to, so the other columns would be out of the screen. So that's why it's only 5 categories. And so here you can see that the actual amount of logging from the different categories. So 60% of the fuel wood is coming from those 2 forests with the 2 highest naturalness categories. And if we are going lower to this naturalness, then the share of the industrial assortment it's increasing, but again, so the size or the area of those forests has the naturalness of this plantation. So the lowest one, it's very small. Again, this middle category is very small, and so from biodiversity perspective, what we can see that this kind of fuel wood problem is not that problematic as this one, but actually the big problem is that we are consuming much more wood from this higher naturalness. And when I will talk about the efficiency of this use, then I will refer back that why this is a really big problem. Okay, let's move on to the that how this biomass is used in the transformation sector. So here in this map you can see that where we have the different biomass power plants. And sorry, I have troubles with the coloring read, but I think this is green. So the greens are the CHP plants. So the CHP plants are those, so these are the so-called combined heat and power plants, where besides the electricity, you also use some part of the waste heat, generally in the local district heating system. And then we have, so here it's Pécs, Ajka, Tatabánya, and there is a newcomer in Oroszlány. So this power plant was closed around 10 years ago, and now they are shifting from coal to biomass. And actually, this already happened in the case of the other power plants. So Tatabánya, Ajka, Pécs, those power plants were used to fire coal. Then Visonta, so this is our only remaining lignite power plant, but here, because of the ETS prices, they also co-firing biomass around 10%. And our only greenfield biomass power plant is here in Szakóvy. Unfortunately, the forest area is missing from this map, but there is not really much forest in this area. So this power plant until shortly after it went to operation, it was closed down for many years, and now they reopened. And interesting fact that except the Harmat power plant, which is owned by the state-owned electricity company, the others are owned by Veolia, so the French giant utility company. Yes, and so just to have like a full picture, I also bring here those district heating which is fueled by partly or solely fueled by biomass. So you can see that now it's getting like busy, this map. So we have 14 other power plants with the biomass fuel district heating, but as you can see, the aggregated thermal capacity it's much more lower compared to the CHP plants. But there is an interesting trend here as well. So the aggregated capacity for the existing one is 44, but there are two newcomers in the system with two big cities, Kaposvár and Kecskemét, and their aggregated capacity is almost the same as the existing 14 plants together. But again, the main focus it's on the CHP plant, so you can see that so this Oroszlány power plant, which will start to operate by around the end of this year. So they are really finishing this whole refurbishment. This will really increase the biomass use. So here we can see the other capacities of the other capacity of the other power plants. And I try to bring together all the important information to this Sankey graphs. So on the left side, you can see that, so what are the different fuels? These are tons, so yeah, the feedstocks in tons. Here you can see the three different categories. So here, the electricity only plants, this is mainly the Matra power plant. Here we have the CHP plants, so this is the three, so Ajka, Pécs and Tatabánya, so without Oroszlány. And here is the heating plant. So it is really interesting that so the actual consumption of the heating plants, it's so little compared to these big power plants. And so on the left, what is interesting that so fuel wood and wood chips, it's the same. So here we are talking about primary woody biomass. Other chips, it's an interesting category. On paper, those are those woody biomass which are not from the forestry areas. But yeah, there are some interesting figures in the statistics on that one. And here are the other solid biomass, straw, and different kind of waste biomasses. And here on the right you can see the so what is the output of these three different kind of three categories. So the electricity only plants efficiency, it's around 28%. So most of them it's waste. So you put like 10 cubic meter of wood inside of this power plant, and the useful energy it's around 3 cubic meter. In the CHPs, the seasonal efficiency is around 50%. This is because in the winter time, when the district heating can use this excess heat, the efficiency obviously goes up. And the main problem that these power plants are also operating outside of the heating season. The main reason is, of course, the economy. So the price of the electricity it's higher, so it's for them it's economically viable to also operate outside of the heating season. And so in terms of the heating plants, the efficiency it's very high, so it's around 28%. But of course, there are also losses within the district heating, so it's only the efficiency of the actual heating plants. And so just to summarize, so around 55% of the wood, of the used biomass, is from primary woody biomass, and so around 1.3 million cubic meters is used by these power plants, which is about 40% of the total total logging. So it's not only the around 50% of the total logged fuel wood, and 35–40% of the total logging. And so it's really crazy. So if the Orstein power plant will start to operate, it will mean an additional 750,000 tons of consumption if it will operate in full capacity. Then, just to highlight that what this actual electricity output means in the country electricity mix. So this very tiny little area is the biomass. So we are talking about like 2 to 4% of the total electricity, total consumed electricity, which is generated or covered by the biomass power plants. So when it comes about, so how can we replace this biomass? We are talking about really very small percentage. So it shouldn't be a problem to replace this electricity by other sustainable sources or simply sufficiency. Then let's talk about that. So how these power plants are operated on the economic perspective. Because it's reported or it's a wind energy source, it means that they can receive state subsidies, and so we have a renewable energy support scheme for I think 15 years now. So they started to get subsidies from the 2003, and so this was like one of the main reasons that, and of course the introduction of the emission trading scheme, that shifting from coal to biomass became economically viable. And so I will just give you some numbers. So in total, they received the biomass power plants 323 billion Hungarian forints. And so just to compare that, of course, wind and solar, they have less capacity, so the actual subsidy per kilowatt hour was quite similar to the wind and for the biomass. But because they had higher capacities, they received higher subsidies as well. And so just to give you another comparison, then we are comparing it with with the social fuel wood program total budget. Between in the last one decade, it was 36 billion forint, and in this decade, the biomass power plants, they received 216. So in terms of like the social aspect, it's also very like injustice. And what is interesting that so this was in the, let's say, in the old scheme. Now we have this premium tariffs system, which means that the state or the energy authority, they launched a call around every 2 times per year. It should have been a technologically independent call, so all kind of renewables could apply for this premium tariff system. But there was one, let's say, special call in 2021, where only those renewable power plants could apply, which were existing for more than 15 years, which means that biomass and hydropower plants were eligible for this call. And actually, the main reason that Oroszlány can shift from coal to biomass is because of this scheme. And so the total amount of money that they can receive, of course, it will depend on the actual electricity price, but the guaranteed price it's around 90% of the total budget of this whole subsidy scheme. So it's very crazy. And so they receive higher guaranteed price compared to the previous quote. So when it was more exclusively solar PV projects on that call. And this guaranteed price is for 20 years. So it means that even in 2044, this power plant will receive probably subsidies. And Gabriele was already told that so there are like indirect benefits because so they are not part of this emission trading scheme, so they don't have to pay for the emitted carbon. And also there is a growing appetite from companies to purchase green electricity, and so there is like a growing European market for that. So this power purchase agreement, and of course as bioelectricity is reported as green, so it's so they can also benefit from this market as well. And so just bring some examples of how it looks in practice. So this is the city of Pécs with this power plant which used to fire coal, and so this is only like one part of this wood store, and it's quite obvious that we are not talking about the cascading use principle here and not biomass cases, but actually wood logs. Sorry for the time, I will be very quick. And so just my last slides about our recommendations. So it's very obvious that so these crazy subsidies should stop as soon as possible. And the household sectors, they are the one who really needs the money to get rid of firewood. And there is also one thread that I want to mention here. So there will be this upcoming social climate fund, which is supposed to support the households in this energy transition. But these funds, it's so the main logic is to support the future increase of the fossil fuel price, which means that there is a big threat that those households who are using biomass, who are using renewables, they will be not eligible for this fund. What is also important that obviously we have to decrease the logging level. I just copy-pasted one sentence from the report from the European Scientific Advisory Board on climate change. So they also highlighted that the one option that how can we really increase the carbon sink or closer the gap in the actual carbon sink and the UNCF target if we reduce the harvesting. Of course, there is a larger scientific debate about the longer term perspective when it comes to adaptation or the carbon or the saturation of the carbon sink, but we also heard arguments before that all growth forests also sink and sequester additional carbons. It's also very important to highlight that we need policies, so it actually means that somehow we have to make this happen, and it means that at the end of the day, we need to say probably to private forest owners that probably you should not log your forest, which of course brings very questions that how can this happen, even with some market support, if the sequestered carbon can be priced somehow, or other measures. I can just repeat what Gabriel already told. So there is a very tiny room for biomass in the future energy system, but in these niche sectors, so most probably in those industrial sectors, cement industry, steel industry, where very high temperature is needed, and of course not covered by primary woody biomass, but secondary woody biomass in line with the cascading use principle. And first of all, we really need reliable statistical data, because now this policy decision is made based on huge gaps, so we don't even know the baseline, the basics about biomass sustainability. So this is something that has to happen very, very soon. Sorry for being long, and thank you very much.